learn what is motion. Basically, we try to understand what is motion. Do we? So motion is a relative word. Motion is a relative word. And motion is compared with the surroundings. When time passes, if an object is moving from one place to the another, then we say the object is in motion. That's what we discussed in the previous session. Okay. So we have also discussed the different types of motions. Translatory motion, and later oscillatory motion and rotatory motion. In class 7th, they have so many topics like different types of motions. They explained with different figures. So according to that, if any object is moving from one place to the another, that can be of three different kinds. Either the object may move linear, the object may oscillate, or the object may rotate. So these are the three different kinds of motion we have seen. But when can we say that the object is in a translatory motion? All the parts in that body moves along the body in one direction, linearly. So from one place to the another, the object moves linearly. Then we say that the object that is in a translatory motion. It changes place linearly. The translatory motion can be of two kinds. One is rectilinear propagation or rectilinear motion, and later curvilinear motion or curved. If an object moves in a straight line, then we say that object is in rectilinear motion. మనం చలనం గురించి మాట్లాడుకున్నప్పుడు చలనము స్థానానితో పోలి ఉంటుంది. ఇది ఒక రిలేటివ్, ఒక దానితో పోల్చినప్పుడు మాత్రమే మనం చెప్పగలుగుతాం. నిన్ననే చెప్పుకున్నాం, సైకిల్ మీద పోతూ ఉన్న వ్యక్తికి సైకిల్తో పోల్చినప్పుడు ఆయన కదలట్లేడు, కానీ ఆయన బయలుదేరినటువంటి స్థలంతో పోల్చినప్పుడు మాత్రం ఆయన కదులుతున్నాడు, మనం కదులుతున్నాం. అట్లా మనం చెప్పుకుంటాం. చలనాలు సాధారణంగా మనం మూడు రకాలుగా వర్గీకరించుకున్నాం అర్థం అవటం కోసం. ఒకటి స్థానాంతర చలనం, ఒక ప్లేస్ నుంచి మరొక ప్లేస్ కు పోతుంది. స్థాన అంతరము, స్థానాన్ని మారుస్తుంది. ఈ స్థానాంతర చలనాలు రెండు రకాలుగా చెప్పుకున్నాం. ఒకటి రేఖీయ చలనము, మరొకటి వక్ర చలనం. వక్ర మార్గంలో ప్రయాణిస్తూ ఉంటుంది కాబట్టి కర్వ్డ్ మోషన్ అని అంటున్నాం. అలా కాకుండా ఒక వస్తువు ఒక స్థిర బిందువు ఆధారంగా అందులో ఉన్న భాగాలన్నీ కదిలితే అందులో ఉన్న పార్టికల్స్ అన్నీ కూడా కదులుతూ ఉంటే అటువంటి మోషన్ ని మనం భ్రమణ చలనము అని అంటున్నాం. భ్రమణ చలనానికి ఉదాహరణ ఒక బంతిని స్పిన్ చేయటం, లేదా టాప్ బొంగరాన్ని తిప్పటం, ఫ్యాన్ తిరగటం, బండి చక్రాలు తిరగటం, ఏదైనా వీల్ తిరగటం, ఇటువంటివన్నీ కూడా భ్రమణ చలనంలోకి వస్తాయి. ఈవెన్ భూమి తన చుట్టూ ఆత్మభ్రమణం చేసుకుంటూ ఉంది. ఖగోళ వస్తువులు ఆత్మభ్రమణం చేసుకుంటూ ఉన్నాయి. ఇటువంటివన్నీ కూడా చూడండి. ఇందులో మనం చూస్తే అన్ని బిందువులు కూడా, వస్తువులో అన్ని బిందువులు కూడా ఒక స్థిర బిందువును ఆధారంగా చేసుకుని అన్నిటి చుట్టూ తిరుగుతూ ఉన్నట్లుగా మనం చూస్తూ ఉన్నాం. ఓకే, నెక్స్ట్ ఇది వచ్చింది. నెక్స్ట్ అట్లాగే మనం నిన్న చూసినది ఇంకొకటి డోలాయమాన చలనం, ఆసిలేటరీ మోషన్. When we speak about oscillatory motion, a particle moves along a fixed point in either side, రెండు వైపులా, to and fro motion. ఏదైనా ఒక వస్తువు తన ఒక బిందువును ఆధారంగా చేసుకొని అటు ఇటు కదులుతుందని సాధారణంగా మనం దాన్ని పెండ్యులంలో చూస్తాం. పెండ్యులం క్లాక్ లో మనం సాధారణంగా అటువంటి దాన్ని మనం చూస్తూ ఉన్నాం. ఇక తర్వాత ఈ విధంగా రకరకాల మోషన్స్ గురించి చెప్పుకుంటూ ఉన్నాం. వీటితో పాటు మనం ఏదైనా ఒక వస్తువు కదులుతూ ఉంది అని అన్నప్పుడు ఆ ఆ వస్తువు ఏ దిశలో కదులుతుంది అని కూడా మాట్లాడుకోవచ్చు కొన్ని సందర్భాల్లో. ఏ దిశలో కదులుతుంది. కొన్ని వస్తువులు దిశతో కదులుతాయి. డైరెక్షన్. Some objects move in a certain direction. In those cases, it is essential to consider the direction also. Not only the magnitude of length, but also we consider the direction. In which direction the object is moving. Let us take a simple example to understand this. Let us take a simple example to understand this. So when you are going from your school to your home, in what way you walk? Of course, if I ask you a simple question, how much distance your house is from the school, what do you say? Someone say it is around half a kilometer. Someone may say it is 1 kilometer. In that way, from a certain place, your place may be in different distances. But if your house is situated towards the east of the school, and if you move towards the left of the school, do you reach your house? I don't think. In this case, to go to your house from the certain point of school, you have to move in a particular direction. See here, we are considering the direction also. If any quantity of such type, which has the magnitude and also direction, then we call that type of quantities as vectors. Vector. In the previous session, some children have asked me what is a vector. Here, vector means a quantity, a physical quantity. Either it is a derived quantity or fundamental quantity, which has either the magnitude and also the direction. Then we say it is a vector quantity. When we are speaking about length, how much length the object has moved. Physically, how much length the object has moved can be called as distance. భౌతికంగా ఒక వస్తువు ఒక స్థానాన్ని వదిలి మరొక స్థానానికి పోవటానికి నిజానికి అది ఎంత పొడవు పోయింది అని చెప్పేదాన్ని మనం ఏమంటున్నామంటే డిస్టెన్స్ అని అంటున్నాం. But if you see the shortest distance between two objects, actually in general sense, actually how much it is aparted, how much it is moved in a short distance in a particular direction, then if we say that length can be understood or defined as displacement. Here we are coming across two different words. The length covered by the object is discussed under two different words. One is distance, the other is displacement. Two things it is very important to know the difference between these two things. One is distance and another is displacement. I don't know why again and again it's coming. Okay. So if we speak distance, actual path covered by the object, usually it is denoted by d, and its units are meters, or centimeters, or kilometers. Distance or length can be measurable quantity. Usually we use scale. Sanat Kumar, whiteboard. Again it is coming. I don't know why it is coming. So here displacement is denoted by S. It is the shortest distance between the original position of the object to the displaced position of the object. Usually it is denoted by A. The units of this is also, I would like to share a screen. Screen. So here, when we are speaking about the distance, distance is nothing but it is length covered by the object. Here we don't consider any direction. But it is only the quantity, magnitude we say, magnitude. The units usually we consider the units are units, what we consider the units are simply a centimeter or meter or kilometer. But here the direction of the object can be in different way. In any way, in any direction, the object can move. The object can move. Okay. Another thing what we are considering is displacement. Displacement is nothing but the shortest distance between the two objects. The first object may be at certain place and it will be moving in different directions. It will be moving in different directions, but it occupies certain place somewhere. Then we can know the difference. No, we can know the value, how much length it has been actually moved. That we can know the displacement. Actually, displacement is denoted by S. This is also length. This can be measured shortest length between the two positions of the object. Shortest length. Okay. Here for this also we use the units same centimeter or meter or kilometer. If it is a big one, it usually we represent it by. Here displacement has both magnitude and also direction. That's why displacement is called a vector. Displacement is called a vector. Whenever we are coming across, whenever we see the word vector, vector means which has both the magnitude and direction. Okay. So here displacement, usually we denote it by S. Okay. Distance and displacement both are different. Now, when an object is moving, how much distance or the displacement the object is covered? The covered distance or displacement is related with the word time. What is time? Can anyone respond? What is time? How can we understand the concept time? Yes, no one is responding. Time, instance between two incidents. Instance between or the gap between any two incidents can be defined as time. Usually when we speak about time, We say 12 hours, 14 hours, 24 hours, or one full year, month, day. In this way, we say so many things. We speak about so many things. But time, a simple definition for the time is instance between two incidents, the gap period between two incidents. That can be a very little one, that can be a very massive one, big one. So the gap between flickering your eye, flickering your eye. మనము ఇక్కడ కాలం గురించి మాట్లాడుకుంటూ ఉన్నప్పుడు కాలం అంటే ఏ రెండు సన్నివేశాల మధ్య వ్యవధినైనా కూడా కాలం అంటాం. మరి కాలాన్ని ఎలా చెప్తాం? ఒక్కొక్కరు పూర్వకాలం నుంచి ఇప్పటి వరకు. హలో, నువ్వా? నాన్న, నేను వేరే మీటింగ్ లో, నేను తర్వాత చూస్తాను. టైం అంటే రెండు ఇన్స్టెన్సెస్ మధ్య దూరంలో ఉండే వ్యవధిని కాలం అని అంటామన్నమాట. అది మీరు కనురెప్పలు కొట్టి మూసి తెరిచేంత కావచ్చు, లేదా స్కూల్ పోయి వచ్చేంత వరకు కావచ్చు, స్కూల్ కి స్టార్ట్ అయ్యి స్కూల్ కి చేరేంత వరకు కావచ్చు, లేదా స్టార్టింగ్ ఆఫ్ ఈటింగ్ అండ్ వాషింగ్ యువర్ హ్యాండ్ మధ్యలో ఏ రెండు వ్యవధుల మధ్యలో అయినా కూడా ఆ వ్యవధిని మనం ఏమంటామంటే టైం అని అంటాం. కానీ టు మెజర్ ద టైమ్ we need a universal scale, universal unit. But how to understand time? If it is, even if you are speaking about 1 hour, it should be same somewhere in the world, also the same gap between the two incidents. So universally it is required. So usually time is measured. The fundamental unit of time is second. Fundamental unit of time is second. A unit of time. ఏం చెప్తాం మనం? Second. But usually we represent that with a S. Second. Okay. But what is second? In what way we can understand second? But in ancient days onwards, people try to understand the time and measure the time in different ways. Most of the, even in villages, or they can say the time during the daytime by looking at the sun. In night times, they can the motion of the stars will, by motion of the stars they can predict the time. That is, they have put some gaps, the what to say, some marks. If it is here, the time is that they're trying to estimate the time. They may not exactly measure the time, but they are estimating the time. But on the whole, first, a solar mean day is divided into so many equal parts, 86,400 equal parts. One part is called second, solar mean day. Today mid-noon to tomorrow's mid-noon, two incidents, today's mid-noon to the tomorrow's mid-noon, two incidents are taking place. The gap between these two incidents is divided into 86,400 times. Approximately, I cannot recall the exact thing. But the one part of it is called second. See how accurately we are measuring the time. It is divided into so many equal parts, and among them one equal part we are calling it as second. So we are measuring the time with a unit second, and later to measure the long lengths, longer periods, then we call it is an hour or a day or a week, so on and so forth. 60 seconds make a minute, and 60 minutes make an hour. In this way, we measure the time. So measuring time, to speak frankly, as and today also, we could not measure the time accurately. We are using different devices to measure the time. In olden days, they depended on shadows to measure the time. There may be a tree or a house or a hut, whatever it may be. Based on that, how much shade it is giving at certain time in throughout the day. Based on the shades, they measured time. And later, the people tried to construct sand watches, sand clocks, or water clocks, and what to say, sundial, different things they tried to use to measure the time. You see, throughout the 365 days of a year, in the same does the same direction sun rises, or in the same direction does the sunset? మనం కాలాన్ని కొలవటానికి పురాతన కాలం నుంచి రకరకాల పద్ధతులను వాడుకుంటూ ఉన్నాం. కొన్నిసార్లు పూర్వకాలంలో ద పీపుల్ ట్రై టు మెజర్ ద టైమ్ బేస్డ్ ఆన్ షేడ్ or sundial you can go for, or sand dial, whatever it may be, water dial. Based on that, if they used to fill some sand in one vessel, for the completion going down into the another vessel, how much time it takes. So that in that way they try to estimate the time. But when the time when we are improving in our thinking mechanisms, we try to have so many devices to measure time these days. We have analog clocks, pendulum clocks. We have analog clocks and pendulum clocks. Every house or every office will have a clock to measure the time on that day, is it? So here, second is the fundamental unit of time. 60 seconds gives 1 minute. 60 minutes gives 1 hour. In that way, 12 hours, half of the day, 24 hours a day. In that way, 7 days a week. See, 4 weeks approximately a month. In Telugu calendars, usually our month will be for 4 weeks. 4 weeks. Even court judgments also will give. It is postponed to 4 weeks, 5 weeks. What is a week? It is a gap of between 7 days. 7 days. In that way, we try to measure the time. So usually we use different type of clocks to measure the time. Sorry. So there are different types of clocks: analog clocks, quartz watches, quartz clocks, and pendulum clocks. Okay, all those are trying to measure the time. But of course, if you observe, if you are using watch, do all the people's watch show the correct time? No, because it is set and it is a machine. It is arranged to work in a certain period. Okay, but to measure the correct time, how can we? These days, the people are using digital clocks. Digital clocks. How every cell phone is having a clock. Every cell phone, and even the children will have wear digital clocks. It shows the number, but does it also show the correct time? It is based on the setting. If you make a 9 o'clock as 7, it starts from 7 only, is it? It is measuring time. But now in the globally, networks are giving internet networks, BSNL or some cell phone networks. When you switch on or when you're on the phone, in all the people's phone, the same time is showing exactly. Okay, in this way, we are trying to measure the time. In science, actually, even the minute value of time is very important to be measured. మనం కాలాన్ని చూస్తూ ఉన్నప్పుడు మనం కాలంలో చూస్తూ ఉన్నప్పుడు చిన్న కాల వ్యవధులు కూడా చిన్న కాల వ్యవధుల్ని కూడా మనం మెజర్ చేయాలి. యాక్యురేట్ గా టైం ని మెజర్ చేయాలి అని అన్నప్పుడు మనం atomic clocks are used. Atom. In an atom, there are some charges. They vibrate with a certain frequency. So this is very important. So to accurately measure the time, we depend upon the vibration of the particles in an atom. Atomic clock gives us ఎగ్జాక్ట్ టైం. మనం కాలాన్ని ఖచ్చితంగా కాలాన్ని కొలవటానికి అనేక రకాల పరికరాలు ఉన్నప్పటికీ కూడా మనం కాలాన్ని ఖచ్చితంగా కొలవాలి అని అంటే మనం ఆటమిక్ గడియారాల మీద ఆధారపడి ఉండాలి. అట్లాగే ప్రయోగశాలలో when we are experimenting in a laboratory, when we are experimenting in laboratory, even all the cell phones might be having clocks to measure the time. Here we have what to say, splitting of time, stopwatches. Yeah, to measure the time, to measure the time, to measure the time, usually we use different clocks. Some of the clocks are analog clocks which have hands in it and they move. Analog clocks we call them, and which display the numbers, we call them digital clocks. And in the laboratory we try to use stop clocks to measure the time exactly between two incidents. Exactly measure the time between two incidents. Let us take to understand one thing here. A pendulum is has to and fro motion. In 10 seconds, how many oscillations it does? ఒక పెండులం ఒక 10 సెకండ్లలో ఎన్ని ఆసిలేషన్స్ చేస్తుంది అనే దాన్ని మనం ఏం చేయాలి, మెజర్ చేయాలి. కాబట్టి at this case we try to use stop clock. So when the oscillation starts, we switch on the stop clock and later we measure when it is passing the mean position, when it is passing the mean position, when it is passing mean position, and count to and fro. So if it makes 10 vibrations or 10 oscillations in 10 seconds, then for every second it is making one vibration or one oscillation. Exactly to measure the interval between the two incidents, we use stop clocks in the laboratory. చూడండి, ఒక లోలకాన్ని తీసుకొని లోలకము ఒక 10 సెకండ్లలో ఎన్ని కంపనాలు చేస్తుందో లెక్కించాలన్నప్పుడు కంపనం మొదలైనప్పుడు స్టాప్ క్లాక్ ను ఆన్ చేస్తాం. అది ఆ 10 సెకండ్లలో ఎన్నిసార్లు కంపిస్తుంది అనే దాన్ని మనం చూసి ఒక సెకండ్లో ఎన్నిసార్లు కంపనం చేస్తుందో మనం లెక్కిస్తాం. ఇలా లెక్కించేటప్పుడు కనీసం మనం అట్లీస్ట్ we have to take the readings for 3 times. The average of the 3 times try to may give the correct value for the time taken for the 10 vibrations or 10 oscillations. So this is also one stop clock usually we use in a laboratory. These days when the competitions are going on, a running competition or some other places, there also we are using stop clocks. Okay, a clock is on when the event starts, then stop is stopped. Clock is stopped when the event ends. ఈవెన్ మనం పోటీలు పరుగుల పందెం ఆటల పోటీలు పెట్టినప్పుడు కూడా మనం స్టాప్ క్లాక్ ని వాడుకుంటున్నాం. సో ఇన్ దిస్ సెషన్ we try to discuss three things. One is the length covered by the object can be discussed in two different ways. One is distance, the other displacement. Now we have discussed another physical quantity, time. Now when an object is moving from one place to the another, ఒక స్థానాన్ని వదిలి ఒక వస్తువు ఇంకొక స్థానాన్ని కదులుతూ ఉంది అని అన్నప్పుడు నియమిత దూరం ఎంత కాలంలో పోయింది అని మనం చెప్తాం అన్నమాట. ఇన్ హౌ మచ్ నియమిత దూరం విత్ the object moved in a specified time. How much of time the object is moving. So when the object is moving, we are trying to understand with what in how much of time the object is moving. That we are trying to understand. To relate these two quantities, distance or the displacement object with time, we call another word we are trying to come across is speed. But how to understand speed? Speed is a concept which is associated with the time. Speed can be written as speed is equal to distance covered by the object in specified time. Speed is equal to distance. See, speed is dependent on two different factors. Speed is dependent on two different factors. Usually, distance is measured in meters and time is measured in seconds. Here, what is S? Here, M is a unit. M is equal to M is meter. Whereas in excuse me. Okay, sorry for the disturbance. Next, S stands for second. This is the unit for meter per second. Meter per second is a unit for speed. Okay, speed is nothing but the distance covered in a particular time. Here, whenever we are speaking about the distance, distance is equal to length covered by the object. Length covered by the object. By any object. ఇక్కడ మనం ఎప్పుడైతే డిస్టెన్స్ అంటున్నామో అది ఎంత దూరం పోయింది అని చెప్తాం అనమాట. యాక్చువల్ పాత్ ఒక వస్తువు నిజమైన మార్గంలో ఎంత దూరం నిజంగా ఏ మార్గంలో ఎంత దూరం ప్రయాణించిందో చెప్పేదాన్ని డిస్టెన్స్ అని అంటున్నాం. It has only the magnitude. It has no direction. It has only the magnitude. చూడండి, ఒక కొంత కాలంలో ఒక వస్తువు ఎంత దూరం పోయిందని చెప్పేదాన్నే మనం ఏమంటున్నామంటే, తెలుగులో గనక మనం వస్తే వడి అంటున్నాం అనమాట. వడి. ఈ వడి అంటే ఏంటిది? దూరము బై కాలం. వడిని ఎట్లా అర్థం చేసుకుందాము? దూరము బై వాటిని మనం ఎట్లా అర్థం చేసుకుంటున్నాం? దూరం బై అగలం. ఓకే, దీని యొక్క ప్రమాణాలు ఆల్రెడీ మనం చూస్తున్నాం, మీటర్ పర్ సెకండ్. కానీ ఇది ఒక చిన్న ప్రమాణం. మీటరు అంటే ఎంత దూరం? 100 సెంటీమీటర్స్. 1 మీటర్ ఇస్ ఈక్వల్ టు 1 meter is equal to, we say it is 100 centimeter. But usually we measure the distance, longer distances. ఎక్కువ దూరాలను మనం కొలుస్తాం. కాబట్టి దానికోసం ఏమంటున్నామంటే 1000 meters is equal to 1 kilometer. Do you know the meaning for kilo? Kilo means 1000. Kilo means 1000. Kilo is equal to 1000. See, 1000 meters is equal to 1 kilometer. It is a bigger distance to measure. So now we are speaking about ఒక వస్తువు ఎంత దూరం ప్రయాణం చేసింది. అది మనం దీనికి సంబంధించిన క్యాలిక్యులేషన్స్ ను కూడా చేయాల్సిన అవసరం మనకి ఉంటుంది. Okay. Let us take a simple example to understand. See, in your class, so many things are given. So now let us try to do some calculations. Sorry. See, let us take a simple 1000 meters is equal to 1 kilometer. Kilo, it is represented by 1000. Here, let us take a simple calculation. When we are speaking about meters per second, we are speaking about speed. So, if you consider this 1000 meters, let us consider 1 kilometer per hour. 1 kilometer per hour. Now let us try to understand the value of this. 1 kilometer per hour, if you want to change that into meters per second, 1 kilometer per hour is equal to how many meters per second? 1 kilometer per hour is equal to how many meters per second? But how to find this? So for this, let us try to do a simple calculation. 1 kilometer is equal to 1000 meters. Is it? 1 kilometer is equal to 1000 meters. Now you try to change this hours value into seconds. 60 seconds is equal to 1 minute. 60 minutes is equal to 1 hour. 60 seconds is equal to 1 minute. 60 minutes is equal to 1 hour. So now we have written the value of hour in seconds. Have we? So if you write the value of this is equal to 1000 by 3600. Okay, 1000 by 3600. Now you try to simplify this value. Now you try to simplify this value. How much you will be getting? So these two zeros cancel. So this value may be written as 5 is divided by 36. Sorry, 10 is divided by 36. Now we can go in two table. Is it? 2 by 18. Sorry, 5 by 18. 18 and this is equal to 2 5s are 10 is divided by 2 18s are 36. See, 5 by 18 meters per second. 1 kilometer per hour is equal to 1 kilometer per hour is equal to 5 by 18 meters per second. Now, let me write this here. So we have found the value, is it? So this is equal to 5 by 18. 5 is divided by 18 meters per second. From this, did you follow the calculation? From this, if you want to write meters per second as the subject of the formula. See here, from this we can alter in this direction. Is it? Now I am copying. I need not to again type Control C is equal to this value. Just I am interchanging their position. Now let us try to write 1 meter per second is equal to how many kilometers per hour? That's what I am trying to write. 1 meter per second is equal to, you see, how can we write? 18 by 5. 18 by 5 kilometer per hours. Just you bring here. What happens? Both the sides 5 by 18 is multiplied. Both the sides to make this as 1. Both the sides 5 by 18 is multiplied. If you do so, what you will get? 18 by 5 kilometer per hour. See, usually in the examination, the questions may appear in such a way that one speed may be given in kilometers per hour, the another speed may be given in meters per second. But how to convert them kilometer per hour to meter per second and meter per hour to kilometers per second? Now we have the conversion formula with us. So if it is given in meters per second, to convert that into kilometers per hour, meters per second and kilometers per hour, you multiply that with 18 by 5. If it is given in kilometers per hour, and if you want to change that into meters per second, multiply the quantity with 5 by 18. Now let us take one. It's okay. Let us take a problem to solve, to interchange. A problem is given in the reader in this way. Let us consider the problem. The speed of a bus, is 72 kilometers per hour. This is what speed of bus. And okay, and another one, Speed of car is around 12.5 meters per second. Meters per second. This is the speed of car. This is speed of bus, and speed of car is the speed of car is around this. In these two, which vehicle is moving faster? Which vehicle is moving faster? ఒక కారు 12.5 meters per second వేగంతో పోతుంది. ఒక బస్సు 72 కిలోమీటర్లు పర్ గంట. ఒక గంటకి 70 కిలోమీటర్లు 72 కిలోమీటర్లు పోతుంది. కానీ కార్ ఏమో సెకండ్ కి 12.5 మీటర్ల దూరం పోతుంది. మరి రెండిటిలో ఏది ఎక్కువ స్పీడ్ తో పోతుంది అని కలవాలన్నప్పుడు both things, the speeds of both, either the bus and the car should be expressed in same kind of units. ఒక పోల్స్తున్నప్పుడు ఒకే రకమైనటువంటి యూనిట్స్ తో మనం పోల్చవలసి ఉంటుంది. అంటే కారు స్పీడ్ ని కిలోమీటర్ పర్ అవర్ లోకైనా మార్చాలి, ఆర్ యు హ్యావ్ టు కన్వర్ట్ ద స్పీడ్ ఆఫ్ బస్ ఇంటూ meters per second. Do one thing. So here we have 1 meter per second is equal to 18.5 kilometers per hour. If it is so, how many meters per second? 12.5 meters per second make how many kilometers? That's what we are trying to find out. So here 12.5 is multiplied with 12.5 is multiplied with 18 by 5. 12.5 is multiplied with 18 by 5 to get its speed in kilometers per hour. So that we are doing here. That let me do here. So speed of car, if you want to change this into kilometers per hour, 12.5 into 5 by 8, 18 by 5. 18 is divided by 5. How much value you will get? Approximately estimate or calculate. 12.5 into 18 is divided by 5. What is the speed? If you simplify, here we can write 5 ones are 5, 2s are 10, 2.5. Sorry, 10. How much? 2.5. 2.5 into 18. 2.5 into 18. Approximately, sorry. If you measure it, if you simplify, this value is equal to 45 kilometer per hour. You see, speed of car is given in 12 meters per second, and when we change that into kilometers per hour, its value is 45 kilometers. But speed of bus is 72 kilometers. Which is moving faster? Which is moving faster? So bus is moving faster. But in general sense, usually car moves fast on road usually, and bus goes slowly. Average distance covered by an express bus usually on the road is 40 to 45 kilometers. But car goes more than 60 kilometers. But in calculation, if you calculate the values, it is real for the given cars. In this way, we are trying to calculate, convert when it is given in kilometers per hour to meters per second, or if it is given in meters per second, and we are converting that into kilometers per hour. So in this way, we can convert. Sometimes in the examination, the problems may We are competing for the scholarship. So this type of problems are also given. Try to practice. If possible, tomorrow we may have some more problems related to conversion. Anyway, it is a mathematics only, but here we are interpreting with the what signs, speed and distance. In mathematics, you might be already converting this, but here in mathematics, usually what I observe is children will solve big problems, but in physics, if a small problem is given, other people are unable to solve it properly. Okay. So with this, I think we have completed what to say, motion and time. Motion, time. Uh, Nani sir join aitara? Shall I continue for some more time? Hello, Nani sir, please delete some messages. Any messages related to the topic? As 5 by 18, 18 by 5. Okay, you are given. Car is moving more fast? No. Our calculation says that bus moves fast. Is it? Bus is moving with 74 kilometer per hour, whereas car moves only with 45 kilometers. So your assumption is wrong. Speed is the distance traveled by unit of time. It is how fast an object is moving. Okay, you are giving the definition. Okay, with this we can complete. Before that, let me put some more questions, multiple choice questions. In what way the questions are asked in the examination? Okay, that is also important thing for us to know, is it? So, which of the following you can respond now? Which of the following is used to measure the time accurately in a laboratory to find the instant of time between two incidents? One is sundial, the other is analog watch, analog clock, or sand dial, and atomic clock or stop clock, which is used to measure the time accurately between two incidents in a laboratory. Analog clock, of course, a digital clock, analog clock may be used, but it has a specific name. Laboratory to find out the instances, the difference between the two instances. Stop clock, of course, it is a stop clock. So in a laboratory, we use stop clock usually to measure the distance. When you are measuring the time or instant, తిన్నానా ఎవరో అయినా తిన్నావా అని అడుగుతున్నాడు. మీకు కూడా తినమని చెప్తే ఇంకాసేపు అయితే ఏం పని ఉంది? ఇక్కడ కూర్చొని ముచ్చట పెట్టుకుంటానికే కదా. Okay. Next, to convert kilometers for hour into meters per second, with what quantity we have to measure? Multiply. If you want to convert from kilometers to meters per second, kilometer per hour to meters per second, with what quantity you have to multiply? With what number you have to multiply? Kilometer is equal to 1000 meters. Very good. With what fraction? Just now I showed you the calculation. Is it 18 by 5? So if it is given in meters per second, to convert them into kilometers per hour, we use 18 by 5. If you want to change from meters per second, kilometers per second to the meters per hour. Just it's reciprocal. Reciprocal, we try to use. Okay. Which of the following has the translatory motion? Which of the following has the translatory motion? You have to say the option. A fan, a rotating fan, a moving ball, pendulum clock, and a swing. Which has a moving ball is in translatory motion. Spinning of top comes under which motion? Spinning of top comes under which type of motion? ఒక టాప్ ని మనం స్పిన్ చేస్తున్నాము అంటే అది ఏ రక స్పిన్నింగ్ ఆఫ్ మోషన్, స్పిన్నింగ్, రొటేటింగ్. బంతిని ఒక బొంగరాన్ని తిప్పుతున్నాము అని అంటే అది ఏ మోషన్ కిందకి వస్తుంది? రొటేటరీ మోషన్ కిందకి వస్తుంది. రొటేటరీ, ద రొటేషన్. ఓకే. Now you have to think. Displacement done by a hand in a clock. Displacement done by a hand in a clock after complete rotation is. Displacement done by a hand in a clock after complete rotation is how much? ఒక ఒక గడియారంలో ఉన్నప్పుడు ఒక పూర్తి భ్రమణం చేసినప్పుడు అది పొందే స్థానభ్రంశం ఎంత? అది పొందే స్థానభ్రంశం ఎంత? Time is 12 hours, of course. Now I am speaking about the length traveled by it, displacement. How much displacement it does. After 12 hours or after 1 minute also, it is, if it is a seconds hand, 1 minute it comes to its original position. It does 360 degrees angle, very good. But I am speaking about the distance. Did it move any place? Even though it moved throughout the clock, and once again, when at the time of instance where we are considering the time, it is on the same place. It is on the same place. So we say that displacement is 0. Displacement is 0. Displacement is 0. Excuse me.